Hey class, so number 70 here was another problem people were asking about. So I thought I would make a small video for you guys. So what we have here is we got this bob swinging around, and we're given in the problem statement what L is equal to. So L is given to us. We're also given the radius of rotation down here, so we can call that R. That's also given to us in the problem statement. And we're asked to determine, based on the mass of the object, and just those two things, so we can put M as a given. Alright, we're asked to determine what the tension is, and we're also asked to determine what the period is. So T is usually period as well, so maybe I'll go ahead and say F sub T for my force of tension, and then capital T for my period. Alright, so how are we going to do this? Right, some people are kind of a little confused. So what I would do, as always, is start with a free body diagram. Since our bob in the picture is purple, I will use purple for my object. And what forces do we have? Well, we can observe that we got the tension pulling up at some angle that we don't know. Call it theta. So that's our tension force. And then we also have the weight of our object, which is straight down, and that's really it, right? In addition, we know that there's an acceleration, a centripetal acceleration this way, but that's not a force, it's just a result. So, cool, sounds good, that looks easy enough. Go ahead and define my axes, vertical and horizontal. We'll call this Y, we'll call this direction X, and so once you have things set up, you're going to want to look at some of your forces. So some of the forces in the x direction equals m times that centripetal acceleration, and some of your forces in the y direction are going to be equal to 0 since it's moving in a flat horizontal plane. Okay, so if we go to do some of our forces, looks easy enough. In the x direction we're going to have Ft, the x component. So if we look, here's our x component. It's the adjacent side, so it's going to be Ft times the cosine of our angle theta. And, well, that's it. Alright, way to go. That's easy enough. And so that will be equal to m times our centripetal acceleration, which we know, if we recall, a centripetal is equal to mv squared over r. That's a sloppy r. And remembering also that v is equal to 2 pi r, having a hard time with r's apparently, r over the period t. Okay, then we can see where that period that we're trying to solve for comes into our equation. Alright, so all of this is our velocity v right there. Okay, cool. So if we want, we can rewrite this ft cosine theta equals m times v squared. I'll just leave it as v squared over r, and then you can make this substitution here for v to get the period. Anyway, but if we look at this equation, oh boy howdy, we don't know ft, we don't know theta yet, and we don't know what the period is. So we got a lot of unknowns in that equation. Let's move on to our y equation and see if that can help. So some of the forces in the y, looking at our free body diagram, and the positive y, we can see that there's the x component of the tension. So maybe I'll make a note here that I'm now looking at the y direction. So we got the x component of the tension, so that's ft multiplied by now the sine of that angle theta, and then we also have in the negative y direction the weight, so minus mg, and that's it, so equals 0. Cool. So we can see ft sine theta equals mg. You can solve for ft if you know theta, but the question is, what is theta? We're not given that in the problem statement, are we? Okay, well, in an attempt to find theta, let's draw ourselves another picture. So we know we got this triangle that can kind of represent our rotation, right? So that triangle that I'm drawing there is really this triangle here, in case you're wondering. So in this triangle we have L as our hypotenuse, the length of our string. We have down here R, which is the radius of curvature, and this here is our angle theta. Oh, look at that. So what I see here is that the cosine of that angle theta is just adjacent over hypotenuse, r over L, and so look at that, we can quickly and easily find what theta is. It's just the inverse cosine of r over L. Now with theta, if we take that theta value here, plug it in over here, we can find ft, since we know the weight. With ft and theta now both found, we can come up here and be able to find what our period is, hopefully. So I'm going to leave it there and let you guys go from here to do the solving. Have a box-worthy day.